over here I would like to discuss one of the case studies which requires a custom design of microscopy system. So as you can see, this was designed initially for inverted microscope. So the way it was built is it uses this type of chamber. This is for microfluidic device, or it can be a MEMS device. It comes with a couple of connections, injections, or controls such as pumps from the top, and we capture the image from bottom. And in this specific case, we designed a custom sample holder which allows rotating this and also moving this in X or Y direction while we capture the system from the bottom and we do the focusing as well. So there are some special cases that this inverted system doesn't work, but imagine that. So we have to flip over our chamber. It is in this shape and we are going to capture from top, and all connections are from the bottom. On top of this, imagine that in this case, because of some connections we have here, either for some physical limitations or for some physiological reasons, the system cannot be disturbed or moved around. So in that case, we will be limited to observing just single spot. But we like to scan and look at different locations or inspect the system to see where what can we do. So basically, in this case, we need to design a movable upright system to be able to move around and capture the image from different locations. So for this purpose, we have used this heavy-duty standby. This allows us to move around in X or Y direction and also rotate this again in X or Y direction and look at a different combination, and this way we can basically cover any region of the sample as an example and inspect the system and then capture the images or videos. The system basically comes obviously with fine focus, and this is very important to have this mechanism, because at high magnification that will not be possible. In this application we are using epi white. The light comes from the side using a fiber optic and shines to the sample, and from top we capture the image. It is also possible that we, instead of reflected bright field, we can do dark field polarization and fluorescence imaging.